The growth of certain flower can be modeled by g of t equals 5 times 1.027 to power 19t, where g of t is total number of millimeters after t hours, which function is approximately equivalent to g of t. So first we have to look to our g of t function and check if we can do something to rewrite our function to different form. Let me copy. We have g of t is equal 5 times 1.027 to power 19t. So this is equal, we have to raise 1.027 to power 19t. This is like 19 times t. So I can rewrite this, that this is 5, and in parentheses will be 1.027. We can raise first to power 19 and then to power t. When we have power to power, we multiply the powers. So 19 times t is 19t. I didn't change anything here, so this is equal 5. We copy, and now we can do this operation in parentheses, in brackets. So we have 1.027 to power 19. We got infinity number, but because in parentheses we have 3 digits after decimal point, so I will round our solution to 3 digits after decimal point. So let me copy this number first. We have 1.6589 because I round to third digits, so I will underline the third digits after decimal point, and I need the next digits to know how I have to run this number. Because after 8 underlined digits we have 9, number greater than 5, it means we have to add 1 to our underlined digits. So we have now 1.65, 8 plus 1 is 9, and everything after our underlined digits we change to zeros. So we don't need to write the 0 because it doesn't change the value of our number. And now this expression in brackets we can rewrite to this form, and here will be sign approximately. This is approximately 1.659 to power, we don't have this 19 now because we raised this expression to power 19, we have only t. And now we have to just check which of the statements is like what we got here. It is the 4. So this is our solution.